I lost track, but it's about Hibernate 6.2. It's on a special day because I can't remember why, but we couldn't make it work on Monday. And we got Christian here to talk about Hibernate. Well, just before we get started, a little bit of news. We do normally release every month, but we have decided to skip this month because of the holidays. So next, we just released Quarkus 3.6, and then in January there will be a 3.7. We'll get into more later on. So anyway, so we thought it'll be fun to talk about stuff that we know everyone uses, which is Hibernate 6. But before we get into that one, Christian, maybe you want to introduce yourself and because I think it's the first time you're on here, yeah. So
Yeah, hi. I'm Christian. I'm working on the Hibernate ORM team, and actually, I have a small slide showing a part of my biography.
well, we can do that. We can show.
Yeah, so I've been a long time contributor to the community, from the community, and since 2020, I'm part of Red Hat, working for Hibernate ORM as my main part of the job, and also the creator or founder of BlazeBit and Blaze Persistence, which is like a library on top. There's also a Quarkus extension for that. And I'm originally from Austria, Vienna, but I moved to Bonn in Germany, I think also 2020. And yeah, I like to play tennis and go for a run from time to time.
Awesome. Hi, Vienna. A lot of people in computer open source right now from Vienna. Like a lot of Graal VM team is from Vienna. A lot
From Austria.
Yeah. So, sorry, not right. What's it called?
Linz.
Linz.
It's like Upper Austria. Yeah.
Yeah. Okay, that's different. Sorry.
That's fine.
Right, you're...
Such a small country.
Yeah. Let's go. So, no, it's fun. Like because I worked in Hibernate in my early days too, but I think you started doing it. I don't know, like 5-10 years ago or something. Is that the
in the community part? I don't know when I started. It's that long ago. It's like I don't know, 10 or 12, 15 years something.
Yeah.
I just contributed small parts at the start, trying to get used to it. Was mostly a user, like many of the people on their team.
Yeah.
And just got better.
Cool. But and as usual, so Christian has a few things he will demo, but if you have questions and stuff, you just put them in chat, and I'll kind of intermingle it into the conversation. And otherwise, I'll just come up with questions because I don't know how to use Hibernate a little bit. So we'll see. But yeah, Christian, if you want to get going, then let's try.
All right, let's do this. So let's.
And you just tell me let me know when you want to share your computer screen. But yeah.
Yeah, let's switch to the IDE. So first of all, I would like to introduce you to this model that I built for this demo. It's an ordering application, so to say, and I was trying to use some of the new features here so you can see it in action. And we'll start off with customer, because of course every ordering system will have a customer. And here's something which you might not probably use in the real world, but for the lack of a better idea, I just took a tax category percentages. So usually you have like products with different tax percentages. And I thought that might be a nice way to make use of the array type that we introduced in Hibernate 6.2, actually, I think. And so you can use a native database array with a fixed size, because usually the different tax categories for a country are fixed. So that was the idea here.
That's so fun to see. I completely forgotten that Hibernate doesn't do arrays, but it's just collections. I just never seen it.
Well, so, actually, it does support arrays, but it supports arrays as tables, right? So it's like all fully relational, not in the sense that it's using the array types natively, which stores them in the same row, but rather as separate rows.
Yeah.
And yeah.
Oh, are these values? Or are they? What are they? Are they?
Well,
Is it?
yeah, it's like a value. So you can imagine that. So usually when you use an element collection, that's what it's called, for these basic values, then you'd have a separate table, and for every element in that array or collection, you'd have a separate row in that collection table. And
Got it.
in this case, there is no collection table, but rather there is, on the physical level on the disk, there will be this row will be on a page, and the array will be embedded in that row on the same page, so to say. So there's no need to join or anything. When the database needs to access that data, it can just grab it from the row data.
Got it. Okay, makes sense.
All right, so this is the customer with the array. The next thing I'd like to show you is an order, and the order has a few interesting parts here. One is an inet address. So I thought maybe it's interesting to showcase the inet data type support that we have now. So I wanted to capture from which IP address an order was created. That's that. And then also what we have here is the partition key. So the partition key is something that helps you when you have native partitioning on your database, because in order for the database to be able to efficiently update or delete a row, it must know in which partition a row is. And sometimes the primary key is not enough as an information source to understand which partition it needs to touch on. And to be able to avoid scanning different partitions and potentially different indices, we introduced this partition key annotation so that people can actually annotate what is the partition key, so that updates and deletes include that in the where clause, so that the database can go directly to the proper row in the proper table or data file.
Okay. Actually, since you talk about custom types, or not custom types that are more supported, there's a question here from Devin. He says, what are the current state of things like Postgres, JSON B fields? Last I looked, I could create custom mapping, but has that gotten any easier?
I will get to that.
Okay, you guys are cool.
Well, not exactly to querying, because I think the question is about querying. The querying part is still not better because we have priorities, but
sure.
It can be modeled right now, and I don't want to forecast the future, but Hibernate 6.4 already introduces some sort of it just has a better support for some array functions, and this progress towards better support for these advanced features will be in the next versions as well. So we're gonna just continuously.
And by the way, that might be interesting for people to know that we're talking like what 6.2 in this one.
Mm-hmm. Oh, I'm not sure. I think you might have been cut off. Your audio does not work anymore, Max. I hope it's not me. I mean, I can hear myself. All right, so Max wrote that I should just keep going. All right, so I was talking about the partition key here, and so as soon as you have the partition key as part of your data model, what you will have to do is you will have to include that partition key, at least in PostgreSQL, also into the primary key. And having it as part of the primary key will also affect how foreign keys are modeled. So here you can see the collection table for the order lines. We'll have to also include that customer ID in the foreign key, respectively. And I can hear you again, Max.
Yeah, sorry, I had a network glitch at that point. So, but yeah,
Okay.
let's hope it goes back. So yeah, just yeah, I got most of what you said. So I think I'm.
That's great. All right. So, but like I was just saying, it's part of the primary key, but not in Hibernate. So in Hibernate, we'll still gonna just use the generated ID, the generated sequence value as primary key, and just mark the customer ID here as partition key. And we'll see how that plays out later on. And next up, the order line, which is just an embeddable here. And this embeddable has a monetary amount data type. This brings us to a different new feature, which is in the mapping area. So here we have this monetary amount type. And as you can see I hope you can see it from the overlay of IntelliJ, it's from Javax Money. So I'm using the Moneta monetary amount implementation, or Java Money implementation. And this composite user type, I just wrote it myself because we don't have an out-of-the-box implementation for this. But if people are interested, we can definitely provide a module with an out-of-the-box implementation for this.
Wasn't there once? Maybe I'm remembering wrong. I thought there was a custom type for monetary amount in the past, or maybe yeah.
There was in the past, but we changed the contracts, and
Okay.
So one of the nicer features of the new contract is that this contract offers a way to access individual components or individual properties of this component. It's indexed by an integer, but I mean that's just a performance measure. We were thinking about doing something like a converter at some point, but we'd like to leave that to the JPA specification because we could easily implement this converter on top. But we need people to like request this, and we also need some sort of agreement in the JPA, or sorry, it's Jakarta Persistence now. I always forget. In the Jakarta Persistence community on how to do this. And yeah, I mean, this is a different contract. And one of the nicer things here is that you can define an embeddable. And this embeddable here is just a so-called projection. So as you can see, the embeddable is modeled here. This defines the actual properties that are exposed to users. So if you're using this monetary amount with this composite user type in your data model, and you have an embeddable then, and you want to query that the components or the individual parts of this embeddable, so extract the amount or the currency in an HQL query, then this embeddable here provides the types of these properties and the names of the properties. So you can see there's this sort of mirroring of the data model side and what you can use as data type in your.
Okay, so the record is just used for, or class is just used for information. It's not actually used. The actual instance is not used.
Exactly. Yeah.
Okay.
But it could be used, right? So that would be.
You could return another one.
Yeah, that would be part of this idea of using a converter, but we wanted to avoid that. Right. So this is the monetary amount. Next up, we have.
Could that literally just be a record? Like, could you just return
it can the record class? Yeah, it can be. I can even change that. That's fine. I hope. Actually, I'm pretty sure.
Save some white space. Yeah.
All right. We'll start the application later. Next up is the product. And the product is not very interesting, but what I wanted to show here is that we have a product category. And the product category itself has a parent category and respectively child categories mapped by the parent category. And this is going to be interesting because we're going to map a hierarchical sort of relationship. And like a quick peek, we're going to use the um, recursive CTEs, the with clause feature that we introduced in Hibernate 6.1, I think, to actually go through this hierarchy and find all of the transitive elements later on.
And that's good stuff. I still remember. I remember the earlier Hibernate having to explain people how to map hierarchical stuff. Well, you could do it, but you have to do your own querying and database specific stuff. That's awesome.
It is, yeah. Okay. Then we have the product variant, because a product obviously is just an aggregation. There is going to be different colors or different sizes, which are usually mapped as product variants. And here is something that people will mostly use, a UUID, but we're going to see in the DDL later on that it will actually use the native UUID type if possible. And since this demo is using PostgreSQL, you're going to see like all of the native data types here. Next up is the product variant details, which is, as you can see from the mapping, just a basic mapping, and or actually an embeddable, but there's a special embeddable. It's a struct. And actually, I found a bug in Quarkus yesterday, which was reported 3 days ago about exactly this sort of usage. And Guillaume was so nice to release Quarkus 3.6.1, like I think yesterday in the evening. And I tried it out and it works. So I'm using Quarkus 3.6.1 now to show you the working of this record. Yeah, so it's a struct, and on the database side, this is an object type, a structured object type, which you can imagine like a class in Java. It's just a object relational sort of extension to some databases. And it's not just PostgreSQL that supports this. There's also support for Oracle. Yeah. DB2 also has support for this, but it's like not very nice. You cannot read it through JDBC or write it. You have to serialize it somehow and then convert it. And nice. Yeah, and theoretically also SQL Server supports it, but you need custom CLR data types. So yeah, that's a pain.
So explain, like, how did you use this again? I never seen this struct before, so this is news to me. So I'm learning stuff here.
Well, you know, it's like an embeddable, just that it's not deconstructed into its constituent parts in the table, but rather it is going to end up as a name type called product variant details. And like this is a composite object.
Okay, so it's still embeddable. We just add a metadata, so we be able to utilize the database support for expressing it with object relational stuff.
Exactly.
Okay.
Yeah, right.
Got it.
Yeah, and actually the attributes here are just for like fixing the order, but for records we don't need that. That's an artifact of the past.
Yeah, I was just about to say, yeah, okay. Got it. So you could probably even remove the name here, just be struct, or assuming that's the naming strategy. Yeah.
The name is actually relevant because
it has to be. Okay, got it.
All right. And
all the what's it called now? The schema generator and updater understands this stuff, or is that
exactly? Yeah.
Nice. I need to go use more Hibernate now. Cool.
Yeah, that would be nice. Yeah. And another thing that I'd like to show here is this JDBC typecode annotation. Like this is something that we introduced in Hibernate 6, which allows you to specify what the type code that we use to find the JDBC type for a basic value is to be used. And the JDBC type implements how binding and reading from the JDBC prepared statement or result set is implemented. And we have we have an extension to the Java SQL types. What is it? Like a constants class. So it's a class that contains constants. And we mapped through the constants of Java SQL types. But then we also added a few more, like JSON, for example.
Remind me, because, okay, so the new thing here is that you can put it on any column, where before you had to have a full column type or column descriptor to actually do it. Is that the...
So actually, in Hibernate 5, we had user types or like named basic types. And With Hibernate 6, we changed that. We're trying to model it more into its constituent parts. So, like a basic type was nothing more than a combination of the JDBC type, a converter possibly, and the Java type. And
Yeah.
I say Java type because that's how we call this class, or interface rather, that implements the semantics of some Java classes. But just to make sure you understand, this is a special entity in Hibernate, or entity. No, that's a bad word.
Yeah.
It's a special concept, yeah.
Yeah.
And you can like model these elements, these concepts separately, and pick and choose, so to say.
Oh, nice.
Yeah, and the nice extensions that we have here is like for UUID or JSON or INET. But the thing is, we need some special codes because the JDBC type codes are also used behind the scenes for DDL mapping, and like we want to like match when you use a special JDBC type that to the DDL type, and through that code, that's possible. We were restricting ourselves to like the JDBC type codes that are predefined, which led to all sorts of problems. But now with this extension in Hibernate 6, we're free to implement anything, actually. You can look into that constants class for more details.
Cool.
So like this product variant type details is not very interesting. Just a record that contains some information which might not be available in all product variants, so to say. So, if that's like a drink, it could have alcohol percent or sugar percent if it's a sweetened drink, and quantity amount or quantity unit might also be interesting. And that's for the product variant stuff. Next up, or actually the last part of this model, is the interval second data type. So, databases have these interval data types, which they use internally when computing the difference between timestamps, or if you want to like add days to a timestamp. And you can also use these data types to model durations, so to say. We're not using that by default because most databases do not support that, and we didn't want to confuse users. If just H2 were using this native interval data type. So we decided to like keep it simple and keep it to numeric and let users opt in. And I just wanted to show it here. It doesn't really get used in any way directly.
Yeah.
But yeah, we have plenty of support for new data types. That's the key message here.
Nice. Yeah. And I guess, the big enabler here is because before we had to have specific custom types or user types. And now with the new one, it's like the things are in the separate constituents, like the type, the mapper, or whatever they're called. Then it's much easier to support more. Yeah, cool.
Oh, see. Seems like I messed something up here. Sorry. Yeah.
Is that the record we changed? Yeah. Okay. It couldn't be a record. Okay.
Right. So let's use restart. I hope live reload kicks in.
Nice.
Oh, I think I need something to drink. But what I wanted to show you here is the DDL that HBM to DDL generates. So one thing you'll notice here is this product variant details type. So you see it's like a special construct. And this product variant details later on will be used. Where's the product variant? Here it is. So it's a special column type, so to say. And the type details is a JSON-B because we mapped it as JSON. Another thing that is interesting is, I think that's new. We're generating check constraints for enums now. You see the INET data type. That's a PostgreSQL extension. Right. So you can just see that there's plenty of new features in here in the DDL parts.
So one thing I remember, because we had We had Steve Ebersole and Gavin on board when we did the Hibernate 6 episode. And here they talk about that the dialects were a bit more, not limited, but instead of trying to support every dialect out there, we now have a set of dialects sort of like these will work for almost anything. And I can imagine some of these new things you're doing, if I jump over to a MySQL or something else, then that just doesn't exist. Do we now just, what happens? Are we trying approximating, or are we just saying, sorry, you can't map? Or is there any improvements there?
Well, I mean, we decided to stop living in the SQL 92 times, and we
It was
started
good time.
to we started to support new features. And supporting new features sometimes means that we cannot support all databases with these features. So some of the new features, which are just nonsensical to emulate or even impossible sometimes, will just produce a bootstrap error. It will just say, okay, this is not supported on a database. We'll have to do something different. You have to use a different mapping.
Got it.
But yeah, I mean, if you're using the core databases that we officially support, which is, the major databases, then usually like all of these databases support most of these constructs. Maybe not structs, like MySQL does not support structs, that's for sure.
Yeah.
But mapping it as a JSON, that's not yet supported because we didn't have anyone interested enough to give us reason to implement it because it's a lot of work. But that's totally possible. So for MySQL, we could totally support the JSON sort of mapping, which has the same storage benefits that this struct would have.
Yeah. Okay. So we had Darren ask here, can control, I guess it says convert between JSON and JSONB on Postgres?
Well, actually, we decided to just stick to JSONB because we don't see a reason for mapping something to JSON.
JSONB is a binary version of a JSON, right? Like where
exactly. Yeah.
So but I guess he's asking if you support both, basically. Like if you have a legacy data, if you have an existing database, can you map a JSON to a thing that is a JSON and not a JSONB? Would be a.
Well, I personally would suggest that people should just migrate to the JSONB data type if possible. And if they can't, they can just use the column definition on this basic, thing on the entities. And I mean, some functions won't work with JSON because, just on Postgres, I think, because Postgres differentiates between the binary optimized JSON data type and the textual JSON data type, and there's different functions.
So you can survive, but please use JSONB is the answer, right?
Yes. Correct. All right, so this was the DDL that HBM to DDL generates. But as you can see, I was trying to showcase table partitioning. And the table partitioning was actually on the orders table, but you don't see any table partitioning in here. That's because we decided table partitioning is something that is not part of the semantics of a table, so we do not want to model this in Hibernate. And what I would have to do, or what everyone with a production system would have to do, is to use a schema management tool. And I chose Liquibase because I'm familiar with it, but I guess FlyWayDB is also a valid choice. And I just modeled the schema as Liquibase changelog. And there's actually tools to generate these changelogs automatically. They work most of the times. You have to after work a bit, but essentially what you're doing is you're using this XML, but you can also use SQL. Just that the XML should be more portable, and essentially just put into all your definition. And what I did here is I partitioned the orders table by hash customer ID, and like I was initially saying, the customer ID on PostgreSQL would then also have to be part of the primary key on Postgres. because Postgres does not support indices or constraints across partitions. And this is what I did here. And I also created free partitions, and I'm going to show how this works later on.
So what you're saying is that in normal case you don't need this, but in your case, because you're basically doing a very custom, or not custom, very advanced model, you are now using the liquid base to model.
Exactly.
Instead of using HPMGL, you use this, right? You're not combining them two. It's either or, I guess, right? Or
right, but HBM to DDL is a development tool, so to say. That's what we try to tell people all the time. So HBM to DDL gives you the DDL that Hibernate expects, but you'll have to craft the alter table statements or the create table statements to your needs, or change them to your needs, because the Hibernate does not know what the prior state was, or if a column needs to be migrated. So if you're just taking what Hibernate produces, you might lose data, because Hibernate will see, okay, this column's missing, this column was added, okay, drop this one, add this one, and what you actually wanted is to rename that column, or try to do some sort of data migration. And as soon as you're at that point, and with a decent project you're gonna get to that point, then you'll need a schema management tool and do these sorts of alter table statements all the time.
Yeah, no, it makes perfect sense. But it means that if you use some of these new things, if you just run it, the schema DL will not be able to do it, because you have to do it. Which is fine. There's no magic wand for this to magically happen. Yeah. Cool.
So I'll just switch over to this model here, and I prepared in the comments here something, but maybe I have to drop the tables manually. I'm not sure if that's gonna work. Yeah, already exists. Okay, I'll just restart the database, I think, because I don't have set up the database connection here in this IDE here.
Yeah.
So give me 1 second. Database restarted. That's the nice things about containers. You can just restart them. Okay, so here's here you can see the update summary. So it ran these 12 change logs, and so now I've been running with Liquibase, and it also imported.
I hadn't seen it. The output you're showing there is from Liquibase. Yes. Okay.
Yeah. This is Liquibase saying it exported successfully. And another thing that I added here is some sample data, because I wanted to show you some queries, and with the sample data it works. And since I'm a Marvel fan, I have used some Marvel names here. I hope Disney will excuse me.
No one sues us. Yes.
All right. So this is the model part. And next up, I'm going to show you some resources, HTTP endpoints, to showcase some of the queries. And we're going to start out with the order resource. So in the order resource, we have, this is, by the way, Java 21. I'm using preview features. So for the sake of, for making it nicer for viewers, because I believe not everyone's going to be stuck on old versions. You can use these features with Hibernate, and it's going to be nicer. So the first query that I'd like to show you is this get all orders query. And what this is doing is it's going to use the join lateral. A lateral is a new feature that we support in Hibernate 6.1, which means that you can refer to aliases in a subquery in the from clause. So that's also a new feature. You can now use subqueries in from clauses, but usually subqueries in from clauses must be isolated. But with the lateral keyword, you can actually refer to tables that have been mentioned, or more entities or entity references that have been mentioned before. So this from order O, this O alias here, would usually not be available in subqueries in the from clause, but with the lateral keyword, you can see here that we're referring to o.orderlines. So it's actually not just referring to this alias, but rather it's creating a correlated like
Yeah, so
root.
so it knows not just the table, but also which columns to navigate on. Okay.
Yeah, exactly.
Nice.
So the idea of this is to just take the two first order lines of an order. So if an order has more than 2 order lines, then we will not see the other order lines. And the idea is I wanted to just give an overview of all the orders. And this overview should include the information about the product that was bought and also the quantity. And if there is more than 2, then we'll just use this ellipsis, comma, ... so that we see, okay.
Okay. Sorry, I was just like, what are you querying? You're creating a new DTO. You're not creating it. It's not an entity. This is a query, the DTO.
Yes.
And you're fetching with some data, which is partial or not partial. It would be summary. Yeah. Okay. Good.
Yeah. It's a summary, so to say. Yeah. So I'm getting some information of the order, and then I'm using this list aggregate function, which is a so-called ordered set aggregate function. That's what the SQL specification calls it. And the speciality of these functions is that they have this within group clause, because I mean they're called ordered set aggregate functions because the elements that they aggregate are ordered, so to say. That's why you need this order clause here. It makes sense, right? If you're doing string aggregation, you have to tell the database in what order it should aggregate. So that's what this order by clause is for. And the main content part here is just trimming the trailing comma 0 zeros, because I have a big decimal as data type for the quantity, and it will just display like the amount of product variants that have been bought. Let me show you how this looks. I have to switch over now. I did not.
Yeah, so the beauty of this is that HQL or Hibernate query language understands, translated into the database specific variant of this. That is nice. Yeah.
Mm-hmm. Actually, I think I have to switch over to a different tab now. I'm sorry about that. I was not anticipating that. This is the Quarkus Insights Swagger UI. You can see all the endpoints, and this.
You zoom in a little bit because it's small.
Oh, I'm sorry. Is this better?
Yeah, perfect.
All right. So we have different customers. I think customer 3 is Peter Parker. And Peter Parker usually just drinks tap water and a pumpkin soup. So this is what the output looks like. Because Peter Parker, until he met Tony Stark, was not very rich. So yeah, he had to live on very cheap stuff. And I think number 4 could be Thor. And Thor eats and drinks a lot. So you can see the ... at the end, because his orders are usually very big. Yeah, so this is how this looks like. Let me switch back over to the IDE. Okay, so right, this is the list aggregation and lateral joining. Lateral joining. See?
Just so quick, I'm not sure what this one is. So I saw Chris' article about CTE support as well. Very nice. What's CTE support?
Well, CTEs is actually something that I'm going to get to later, because I'm going to showcase a recursive CTE.
Got it. Then we'll wait with that.
Okay.
Go ahead.
Right. Lateral joins, as I wanted to finish off, is also a mean to solve a common problem called the top n per category problem. So usually when you have like this category, like it's the concept, right? Order is the category, and for each of those categories, you want something, you want the top n elements that are associated with it, right? So this is like, I want the top 2 order lines of an order. This is a problem that's usually not very easy to solve. I can show you later on how to solve it because of a bug in Hibernate ORM. I had to implement it by hand. And yeah, since I had to do that, I just wanted to mention it. And you're going to see why lateral joins are way more comfortable for this purpose. And the rest of the methods here are not very interesting. So it's just a get order by ID and creation of orders. So we're going to skip over that. Next up, I'm going to show you the order processing resource. And this is not very interesting, but I'm going to show you how the partitioning works. So the start order method here is bound to the post action for the order ID. And it's just gonna change the status to in progress. And let me switch over again to my browser. So this is the wrong one, admin order post, that's it. So in my IDE, we will see just in a few seconds, as soon as I process this order with response code 200, we're gonna see that it will include in the generated SQL the customer ID in the where clause. So you see it updated the orders, the status, just like the code envisioned. But it's not just using the primary key, because just the primary key would run into exactly that problem that I tried to explain in the beginning with the partitioning, that the database, or PostgreSQL in particular, would not be able to understand which partition to use for finding that order. And by using the customer ID, a database can actually go to the right physical table or data file directly.
Is this different than what we called tenants before, or is that the same?
It's kind of related. I don't know if you would want to like partition by tenant all the time. That's a possibility, but yeah, it's an orthogonal concept essentially.
Okay, yeah, it's not just a more generic version of it.
Right. I think the prime example would be to partition by date range. So you would have orders, and you would say for every month you have a separate partition of orders, so that you can have like a historical orders, so to say, partitions, and the current orders partition, because usually you only need certain indices on recent orders, right? And on historic data, you wouldn't want to like spend all of the cycles for index maintenance or whatever.
Got it. Okay, makes sense. Yeah.
Okay. So next up is the product resource. We're gonna look at this recursive CTE. Sorry. So we have this get method here, find products, which receives product query DTO being param. And this is not very interesting. It's just containing some filter query parameters. And the category ID is actually the most interesting part here, because applying a category filter with hierarchical categories, it's not so easy, because if you're filtering for a category that has subcategories and product variants are assigned to the subcategories, you will have to first determine all of the child categories of a filtered category to be able to understand which products or product variants are actually associated to that tree of product categories. And this is something that I implemented here. That's the product variants filter. Product filter, that's the one. This is using JPA criteria. And I can tell you, using HQL would make this way easier. But since this is dynamic, and I also wanted to show that these new features are not just part of HQL, but are also part of our JPA criteria extensions, that's why you're seeing this one here.
Okay. And what's the CTE? What does it stand for?
A CTE is a common table expression. That's the term that SQL uses. It's essentially the element of the with clause. So the with clause is like a let expression. Maybe you know that from other programming languages, where you can just specify like a named expression, and then you can refer to that named expression in later expressions.
Got it.
Yeah. But the with clause has something interesting, which is called a recursive CTE. And you can start off here with the CQ object, that's the criteria query object, or GPA criteria query, since it's the extension of Hibernate ORM. With this function here, I'm saying, okay, this is going to be a recursive CTE, and I'm going to connect these two with the union distinct qualifier. So people usually know union all, which means it will not eliminate duplicates, but will just retain duplicates. But the union distinct operator, set operator, instead will make sure that duplicates are removed. And yeah, we don't want duplicates, obviously, in this case. But every recursive CTE is composed of two parts. And the first part is the base. So you have to start somewhere, because even though it's called recursive, it's actually more iterative. So you have like this initial object that you're starting off from, and then you have this inductive part, which will refer to the previously found elements and extend the set of resulting elements based on that. So this base here, we're going to use the category that we're filtering against as this base. And the union part, the recursive or iterative part, will then use this CTE. So this is like a self join. This is where this recursion or iteration comes from. It will read the data that it has read before and join against that a product category. And it will say, okay, give me the category that has, I'm sorry, the parent category of this existing data. So it's essentially just following down the child categories. Okay. And then in the end, I'm sorry.
Okay.
Talked too much today already. So it will end up in sorry.
It's also been the season of sore throats, so that works.
Yeah, I'm sorry. Sorry for all. Yeah, and in the end, it will just take that CTE and just read through all of these transitive child categories that have been selected through that CTE, and just use the equality predicate to check if the category of a product is in that subquery. And this all sounds very complicated, but if you see the resulting SQL, you'll see it's not that hard to grasp. Okay. So let me show you how this actually looks, and I'm not gonna switch the sharing again. I'll stick to IDE.
Yeah, you just
show
doing
the
the
resulting
HTTP
query.
Yeah.
So first, I'm going to filter by category ID 1, and this is like this parent category that has like drinks and so on. And you can see here the query. The formatting is actually not very nice, unfortunately. But here's this base part. The base part says, okay, take the category with the ID 1, which you'll see here in the bind values, bind value 1. And then this recursive part, where it's referring to the CTE again in the from clause, and then joining product categories again against the parent category ID. And this complex part, which was the one about the equality here, you'll see it's just this any subquery. So it's pretty simple, actually. But what you will see in the result, which you cannot see, unfortunately, because I'd have to switch over again. Or maybe I can switch over now, because that's important to see. There we are.
Oh, good. There we go.
Yeah.
Yep.
So here we have tap water. It's category ID 2, actually, not 1. And juice, category ID 2. But then we have also alcohol, category ID 3, even though I filtered for category ID 1. So you see it works, obviously. If we filter by category ID 2, then we will not see alcohol. We'll just see apple juice and the orange juice also, because it's a different variant, and tap water. And yeah, same goes for if we filter for free, which is alcohol with the rum here. Okay, so
Cool.
another thing that I haven't showed is a performance feature of Hibernate that we added. Which is the possibility to say, don't copy the criteria tree. Because JPA says the criteria query is mutable. And Hibernate, sorry. Right, and Hibernate has to obey these rules. Hibernate has to do the copying of the criteria query because it could be mutated later on. But what you can do is set this property. And then Hibernate will not copy the criteria query, resulting in better performance and in the future also in more caching.
So when you say this is just about the criteria, like it's just the avoiding having to copy stuff when we create the query, is that the?
That is correct.
So it's yeah, so it's a pure like raw performance thing. Okay, got it. You muted, Christian.
I'm sorry. Another thing that I wanted to show is how the structs are selected, actually. So you can see here that details is a struct, right? And what will happen is we will take the constituent parts, description and color, out of the struct with this special syntax in PostgreSQL. On the other hand, the type details, which is JSONB, will not be selected in its constituent parts, but rather as a full JSON and will be parsed on the client side.
Got it.
Right. Next up is the statistics resource. And for the statistics, we have a few reporting queries, which are interesting. First up is this query here. Give me 1 second, please. I need to. Okay, so way better.
Good. No problem.
So this query here is interesting because it's using this filter clause. That's a SQL concept, which allows you to change what is included as part of an aggregate function. And it's interesting because people usually work around that by using a case when statement in the argument part of the aggregation query. Because they are using the fact that aggregate functions reject nulls. So if you produce null, then it's essentially a filtering of the data that goes into the aggregate function.
Yeah.
So this filter clause is supported on some databases. We're going to render that if possible, but also emulate it if needed. But it's just a new nicety that HQL offers you.
Okay, so wait. So just make sure. Okay, so the OStat is filtering. It's going to ignore rows where the order is cancelled.
Exactly.
But it's still going to include cancel in the actual result. It's just that you don't sum them. Well, what was it? The sum of the quantity where it's not cancelled, and then the coalesce is doing what? Sorry.
Well, we could actually also implement that as a filter. So we could just move that out here, like this. So this would only be interesting if you want to like aggregate multiple different things. And you wouldn't want to exclude canceled for one aggregation, but only exclude it in a different aggregation. So say you want to aggregate the amount of the quantity of the ordered products, but still want to count all of the products, for example. Then you'd have to use this filter sort of logic, because filtering it on the query level is going to exclude those orders and products from the counting.
Yeah. Yeah, so that's what I'm saying. Like when you put the filter back we have there, the actual query will have cancel order in them, but it just can't do the sum on them, right? That's to have it right there.
In this particular case, it's just the same, right? But what we could do here instead is we could say we want to count all of the let's take the distinct products like this. So here it makes sense, because you want to count all of the distinct products that have ever been involved in an order.
Yeah.
But you only want to count or sum the quantities of products that were actually delivered or ordered. So essentially that do not have the status canceled. So here it makes sense. Moving the where clause here to the main query would change the semantics, because that would affect the count as well, which we don't want sometimes. Does that make sense?
Yeah. No, it does. Yeah.
Okay, perfect. All right. So another thing that is shown here is the fetch first clause, which is also a nice new feature. And it's not just a set max results that you maybe know from JPA on steroids. It's actually more of something that provides you additional benefits, especially this rows with ties clause here. So say, for example, you're ordering by something that might produce non-unique orderings. So say you have two products that have the same amount that is sold. If you were to use a limit clause, or fetch first with rows only, then it would just non-deterministically, I think, stop at one row or the other. So this is usually called a tie. So when you have two rows that have the same ordering according to the order by, then it's not deterministic which of these two rows will be taken. And I'll be showing an example in a few seconds. The rows with ties clause allows you to say, okay, even if I have to select 6 instead of 5 elements, that's fine for me if the 6th element is a tie with the 5th. Do you see where this is going? So if you have a race and two racers are entering the finish line at the same time, then you'll have two people on the same podest level, right?
Yeah.
That's the tie. So this is one of the nicer features, which is actually pretty good emulated with window functions, so you can use that on all sorts of databases. And an example. So this is the top products. Now I have to switch back and forth. Sorry about that. I wasn't anticipating that it was this hard to switch the source of the presentation. Okay, so the top product is the thing that we just saw. And what we want here is sorry, I'm hearing. Can you please back? Oh, thank you. That was bothering. So if we want to take the top one element, we're going to see how the ties work, because it will not return just one element but two, because both of these products, product 4 and product 1, have 20 amount of sold elements. So this is where the tie takes in. 2 will obviously also return 2, and 3 will return the additional 1. And yeah, that's the example. And before I switch back to the code, because I don't want to like switch back all the time, I'll first show the example this time, because now we're going to see the top products by quarter. And what this means is that we're going to see for every quarter, we're going to see a number of products that is the top most sold in that quarter, so to say. So we see in 2023 fourth quarter, product 4 is sold 15 times, which is the top sold product, and so on. And what we can do here is we can also change the limit, so we can see more products, so the top 2 within that quarter. So we see product 4 was sold 15 times and product 1 was sold 15 times as well. And you'll notice, oh, this is a tie. Is this not using the same with tie semantics? No, that's on purpose. Yeah, you can just see that there's tap water and the soup is said very often. So let me switch back to the code, because this is where I was using this emulation of the join lateral that I was telling you about in the beginning. And it's actually quite complicated. You can see there is nested subqueries here. And the basic part here is that I'm taking the order and all the data here and summing it. And I'm also preparing the time period, because the time period I'm interested in is the quarter. So I'm truncating the creation date of an order to the quarter part. And what I have to do then is to create the row number. And since the row number cannot be used in the where clause, we have to do this double wrapping. And we determine the row number within each time period, and then have to order. So this is our rank, and in the end we're taking the configured limit and say we want only the elements that are lower than the given rank. So if we want per quarter 2 top products, then 2 is going to end up here. And this is how you would implement this or emulate this lateral join. And yeah, like I said in the beginning, due to a bug, I had to implement this by hand. And the rest is not so interesting. I'm using this last quarters here, which is a recursive CTE, just to generate some values. I'm starting at the current instant and then going back 4 quarters to generate the last 4 quarters, which is also quite useful sometimes. But yeah, that's this query. Quite the beast.
Quite the beast. Okay. So the new feature here is just, the
window functions.
Yeah.
That's a new part. And I'm just showing window functions 1.0. There's window functions 2.0, which involve sliding windows and configuring the frame start and frame end. But this is dependent on the database support. And yeah, it's
I can imagine there's a lot of power that this gives.
Yeah, but it's
a science. You can let the database do the heavy work. Yeah. Sorry, what? Yeah, the science in itself. Yes. Yeah. Sure. So, Christian, just a time check. We are on over an hour now. I don't have a hurry, but just so you know that.
Okay, I have one last example, and after that, I think we can go to questions if there are more questions which I haven't answered yet. And that's this rollup example. So rollup is a summarization function. I don't know if the SQL spec calls it like that per se, but that's essentially what it does. So usually when you group by, you're aggregating for a group. So you're saying, I want to aggregate for this quarter, or I want to aggregate for a date or for a month date. And what you then want to do maybe is to aggregate subparts. So if you have monthly resolution data, you might want to aggregate that into quarter basis, or then get the overall aggregate. And this is where these summarization functions like rollup come in, where you can say, okay, I want the aggregation data per month, but also per quarter and the overall. This would be the prime use case here. Or other examples that I found on the internet is if you have like hierarchies, if you have like multiple warehouses within states or within different countries, then maybe the states or countries and warehouses are like these dimensions across which you want to aggregate. So you want, for example, the sales that happened in one warehouse and then aggregate them by state, or and then in addition by country, and then the overall sales maybe as well.
Excellent.
That's about it. The other examples is just showcasing some of the temporal features, but I think we're past time.
Sure. Oh, awesome. Yeah, the temporal one, was that a 6.2 thing? The stuff about dates and comparison? Was that earlier?
Yeah, I think 6.2.
Yeah, okay.
Yeah, sorry for my cough. I'm still recovering a bit. Still not fully healthy.
No problem. As long as as long as it doesn't carry over the internet here, then it's fine. Yeah. So, do you want to go back to the presentation? We had a slide or two.
Right. I mean, I just wanted to give you a quick recap of what we saw. So, the new mapping improvements, JSON type, struct, UUID array, the partitioning example, the composite user type for monetary amount to bridge the gap between, these custom user types and the embeddable world of JPA or Hibernate ORM. And then a bunch of Korea language improvements, things that have been requested for years, recursive CTEs. Finally, it's there. Window functions. You don't have to fall back to plain SQL anymore. And we're going to take care of some of the vendor specifics. Lateral joints, which are also emulated. Simple parts of lateral joints can be emulated. More complex ones are very hard. So you might see some errors here or there if your database does not support it. But usually, we tried very hard to make it as usable across different databases.
Do we detect? Is this in a class of do we detect them, or is it like we are best effort and then there might be some differences, or?
I'm not sure I fully understand.
Well, I'm just thinking like the CTEs and others. I can imagine that in some cases you can mimic them completely. It's just more verbose. But in others, there might be cases where you can only get approximation in the database. Do we do the approximation, or do we fail hard? That was my question.
So
we fail. Okay.
Recursive CTEs cannot be emulated, so we have to fail if the database does not support it. I mean, it cannot be emulated efficiently, so that's why we chose to not do it. And most databases support it anyway. Even MySQL 8 supports recursive CTEs now.
Cool.
But a CTE itself is just a subquery in the from clause, essentially. So if the database does not support it, and I think there are a few, then we actually just inline the CTEs into where they're used. And this always works usually. You can read the rest of the features. You saw all of them. It's very much, and maybe I even forgot a few things. I'm sorry if I didn't acknowledge every new feature of one of my colleagues. Yeah, that's about it. So if there are any questions, now's the time.
There's people who want me to have a headphone because I'm generating echo, but that's I'll try. Otherwise, there's Postgres. Otherwise, we've been through. But you covered a lot of ground. And that was awesome. I learned a few things, so that's even more awesome. So that's cool. And we'll put the link to the thing on the video. And it's also in the presentation. You can see it. And then that's good. Any other last famous words, Christian?
No, other than look forward to the next Hibernate versions. We're not done yet.
Yeah, and I know like 6.3 and 6.4 is having all this stuff about like doing repositories and queries in a more what do you call that? Nicer way. But yeah, we definitely will. I think we'll see you next year, Christian, once we get that integrated in, and looking forward to that one. So yeah, that's the. If you use Spring Data, they had this approach that's been popular, and we've always kind of had a what's it called? Non-happy feeling about it. Is that a good way? But there's now in 6.3 that's coming, and yeah, we'll have that in the episode next year. So cool, Christian. But thank you for the 6.2 update, and yeah, we'll see you on the other end when we get there. So thank you, and I'll end the stream here.